Swayam Prabha. Digital India. Educated India.
Then I'll go to how we can optimize functions. Okay. Functions. See, whenever I have a function call, say I'm making a function call foo, or in Java, since if I'm doing a.foo. Okay. Can someone tell me what happens when there is a function call? Oh wait, it hasn't refreshed properly yet. Why it hasn't refreshed? Okay. I hope the slide 39 is visible to all, right?
Yes. And foo and a.foo.
Yeah, that's the only thing I've written.
Is visible.
Yeah, good. So now, can someone tell me what happens when we make a function call?
To save parameters on the stack and then jump.
Okay. So this foo is being called, let us say, inside a function called bar. There are many local variables here. During executions, there are also registers and all that. So when we make a function call, there are additional things that you have to do. Save, locals, registers, jump. In foo, again, I have to, I may have to save save a bit more of whatever the parent of the caller. Save some more.
Return well.
So when we are studying about code generation, we will talk about it. But just be aware that in the beginning of the function, you will save a few more. Then you have the body of foo to be executed. And at the end again, restore a few things. So this is my foo. And then jump back. And then whatever you have stored, you will restore. Right? So every function, this is all the overhead of the function. This part, this saving part, this restore, and this restore. Okay? Every function call is expensive. Then why do we write functions at all? Can someone tell?
To make it modular and
Exactly. Usability, modularity, easy to read, and all that. So functions are a necessary evil kind of. So what the compiler does is, wherever possible, wherever it finds it useful, it takes a function and inlines it. What is inlining? It looks at this code, this call, and replaces it with the body. Okay. What did I say? In function inlining, I'll replace the body, the call with the body. The code size has increased, clearly. And I said, if function calls are leading to some overheads, okay? Let me ask you this. Is there any performance advantage of keeping function calls? We now so far said because of function calls, there can be performance degradation. But because of function calls, can there be performance gains?
if there are too many calls.
No, I'm saying too many calls is bad. That's what we are saying, right? What I'm now saying is there a possibility that no, it's not a general rule. There can be cases where because of function calls, my performance is improving. Not inline, because of function inlining. I'm saying because of the calls, the performance is improving.
Yeah, following up on what Rajni said, many calls to the same function will give us a cache hit.
We'll give a cache hit, which is, but I mean, instead of making that call, I can keep the code as it is, isn't it?
Yeah, but it will go on hitting the cache get reloaded again and again, right?
Sorry, repeat please.
Right. The cache gets reloaded again and again, right? I mean, there will be a cache miss.
Why will the cache be reloaded?
Because the function is going to be replicated across multiple areas of your code.
Oh, okay. So you're saying, let us say I have a function foo, which is called at different places, not inside a loop called again and again. Okay, so if I have foo like this, then the instruction cache gets reused.
Yeah.
Okay. Very good. Anything else? Okay, so there are advantages of having functions. It's not that functions are necessarily evil. They have their evil side as well, but fine. But what the compiler does, that's why it looks at a function and sees if it is a small function, okay, and it feels that if I inline it, it improves the cache behavior. It does not impact the iCache. That is, if the function is too big, right, it may impact my iCache. So if the function is small and the overheads of saving, restoring can be eliminated, and the gains due to inlining is more, then the compiler will inline. It's a very popular optimization. So how do I inline? Let us look at the procedure. Okay. Any questions on the pros and cons of function calls and the function inlining?
I had this question, like, so then why does a compiler not do inline for every function?
See, if you inline every function, the code size will become too big.
Okay, that's the only reason that.
Also, can you inline a recursive call?
No, that will just keep on getting increase the code size a lot.
And here is the statement I'm making. Inlining can increase the code size exponentially. Can someone give an example when such a thing can happen, or give an intuition why such a thing can happen?
The recursive call.
No, it's not inline, and that's not an exponential blow up. If you keep on inlining recursion calls, it's a forever process. It's not exponential. It will not terminate. So we will not even inline. Most of the time, we don't inline most of the time we do not inline recursive calls. But the statement I made still holds, that inlining can increase the code size exponentially. Anyone? Come on, guys, think. Anyone who has written, I mean, you have to kind of think in terms of code. In compilers, most of the things, right? It should be it's able to see these things in terms of math and code.
So if a function is called inside another function,
okay.
So and we are inlining the bigger function, and the function that is being called inside this function is also being inlined, and that can cause the exponential growth.
Look, I had three functions. Let us say A, B, C. Inside B, I'm calling C. That's what you're saying. And inside A, I'm calling B. Correct?
Yes.
So fine, I will just, so size of A will become size of B plus C. It's not exponential here. It's increased but not exponential. But this is the right way to think. Think of some piece of code and think.
So A calling itself 2 times. Like
So that is recursion.
If we have a function call within a loop, like for loop or
For loop makes no difference. If I have a for loop, right? I'm inlining it only once. I've inlined it only once, right? Not, it doesn't depend on n. See, loop unrolling is different, loop inlining is different.
Would
Inlining is different.
mutually recursive functions?
No, we totally ignore recursion, direct or indirect. Power function, what about it? Let us take a simple code and see, let me see if this its beauty surprises you. Let us say I have a simple code function A which calls B twice. Okay? B calls, again, B is a simple code which calls C twice. C calls D twice. This is just a function call. Huh? Just a call. All these are simple calls. And D is a simple statement, some statement else. Now can you tell me what would be the size of A? Here the size of A was 2 statements, B was 2 statements, C was 2 statements, D was 1 statement. What is the size of A here? Can someone tell?
Twice the size of B.
Sorry?
Twice the size of B if you don't inline.
Twice the size of B. What is the size of B? Twice the size of B. What is the size of C? If C is D is 1 statement, C is 2 statements, B is 4, A is 8. So exponentially the size of A is increasing. If it is kind of 4 or 5 levels, it will go to 32. So big, right? So there can be an exponential blow up. So someone asked why we do not inline everything. Was it Jasmine, right?
yes, okay, I got it.
Right. So what the compiler does when they are doing unrolling or inlining, they are very careful about how much code size are they increasing. If it increases beyond a number, they typically hard code the number sometimes. They won't inline. Okay. Pros and cons of inlining. Okay, let us see how to do inlining. Okay, to do inlining, let's say I have a function foo, which is being called in bar. Bar can have its own locals, right? Let's say bar has a variable int x. Okay. Foo itself can also have locals, right? And we know that this x is different from this x. Correct? Foo may also take some arguments. Let's say it's taking an argument z. Here it could be int p. Foo may also return something, return y. So I may write s equal to foo. Now how will I inline? If I just dunk this code as it is, what will happen? The code for bar will look like the original code, whatever, with int x. And then I will immediately, if I dunk this code, what will happen to p? I need a variable for value for p. So I have to write p equal to z. Okay, and then I will write int x. This is redeclaration, isn't it? And if I write return y, where will I return from? Foo or bar? Remember, I'm just dunking this code here. So this return y will return from bar. We don't want that. Instead, what do we want? We want, instead of return, we will write s equal to y. So what will I do? I will replace, I'll rename all the locals. I have to pass all the arguments. So this is like copy arguments. So this int x, I will rename it. Let's say I'll call it x1 and do all these things will be renamed. This is rename locals. And this one, return, replace, return with a copy. But I also have to come back. See, there may be some code after this return. I should come back. So what should I do? Can someone tell me? See, if I have if condition return, right? My code was if condition return. What should I do here? Can you think of it? So one thing I could do, I can replace this return with a goto. So what will I do? If I have code in my function foo that I'm inlining, if condition return y, I can replace, I can kind of generate code like this when I'm inlining. In bar, there is a call to foo.
We are not able to see the code, like
You're not able to see the code, sorry.
the transition is causing this.
Okay, wait. Yeah. So if I have a function foo that I want to inline, where I want to inline this function foo, it has a conditional return. Then what will I do? I'll replace this foo with if some condition. Okay, I will set a new variable called underscore return equal to y, and then go to L1. What is this L1? L1 is the end of this code, L1 here. And L1 I write s equal to underscore return. So I may return at different places. There is if condition return y, else return z. So I will again write underscore return equal to z, go to L1. Okay. So I did three things. One, copied the parameters. Two, rename variables, variables local to foo. Three, replace return statement. Are the three steps clear for inlining?
Yes.
Okay. I'll do one thing. I will take 5 more minutes and wind up. There's one more cool optimization called tail call optimization. Do you know what's a tail call? A tail call.
Okay.
Yeah, go ahead, Rupanshu.
Function call, that is the last instruction of
It's the
another.
last instruction. As in, after executing that function, I do not have to execute anything else in the current function. So let's say I have function foo. If the last thing is a bar and I don't return nothing, or I may be returning bar, then this is a tail call. Okay? Just a minute. Hello? Yeah, yeah. So this bar is a tail call. But let us say I have a code like this. I am calling bar 1 and bar 2. This is not a tail call, this is a tail call. Because after this bar 2, foo does nothing more. If I have a call that looks like this, if condition bar 1, else bar 2. Okay, and there is nothing more after this. Then again, these two are tail calls. Because in foo, after bar 1, I am doing nothing. Or after bar 2, I am doing nothing. So do you understand what's a tail call? A tail call is a call where after the call is done, you don't have to, I mean, when you return from the call, there is nothing more to be done in this caller. This is the caller, this is the callee. So once the callee is done, caller has nothing more to do. That is called a tail call. Okay? You know what I can do for a tail call? Can someone guess?
Not return back to foo.
All right. And return, okay, instead of returning to foo, where should I return to?
Like who the caller function for the foo.
The caller of foo. Very good. Very good, Abhinav. Very good. So what I will do, I'll go one step further, Abhinav. I will not even call bar 1. Instead of making a call where we save, restore everything, this is what I will do. In place of this tail call, let us say I have a call, function tail call. I will instead do go to wherever the tail call function is. I'll replace the call with a go to. So since it's a go to, I will not save and restore nothing. I'll directly go there, start executing da 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 da, and then when I have to return, I will automatically return because this return address is that of my caller, isn't it? See, foo has stored the return address somewhere. I will just do a go to. So whenever I encounter a return, I'll automatically return to the caller of foo. How cool is that? Whenever there is a tail call, I can replace it with a go to. I will leave something for you to imagine. If I have a recursion, okay, something like factorial function, right? Do you remember your favorite factorial function? If n equal to 1 or n equal to 0, return 1, else return this one.
Factorial of n minus 1.
If I write n into factorial n minus 1, this is not a tail call because after you return, you're doing something more. Okay. So instead, what I will do, I will write a slightly different variation of factorial function, which will calculate, which will carry int n. I'll carry one more, which is the product. Okay, if n equal to 0, I will return p. Else, I will return factorial n minus 1 p into n. Okay, this is a tail call. Okay, so what am I doing? I am continuously multiplying and passing the argument. In the second argument, I am passing the product. Okay. Try replacing it with a tail call, and then within 1 or 2 steps, you will realize that it will become a loop. Okay, you can actually replace a recursive call with a tail recursive call with a loop. I'll leave it as a fun exercise. Any questions on tail recursion? Otherwise, we'll
Still, still save the parameters to the function on the stack, or we don't need?
We don't do nothing. So we'll just copy the parameters and jump. So here I showed with no parameters. If there are parameters, you have to copy the parameters appropriately.
Yeah.
Yes. Okay. Fine. So if you remember, we started with this many phases in a compiler, right? Let me see. Still not refreshed. Let me refresh. Okay. And we spent some time understanding machine independent optimizations mostly. Okay. Some high level optimizations. So that's what it is for our session. If you have any questions, I'm here available. Or send me an email. As I said, my email ID is available in the slides. Any questions?
Hello, sir.
Yeah.
So in the loop inversion, we talked about converting the while loops into the do-while loops, right? And
Yes.
it improves the pipelining concept. So can you put a light on it? It's a little unclear for me.
So we are reducing the number of branches, right? Branch instructions. And as you correctly mentioned, the branch instructions are bad for pipelining. And also I'm reducing one conditional branch altogether. Correct?
Previously, there was one conditional branch and one unconditional branch, right? After
Correct.
doing a do-while, we are having two conditional branches.
No, we only have one conditional branch. Let me see if I still have the code as it is. Oh, we have the code. Very good. So I have only one conditional branch in the loop. See, this guy is gone. I had one conditional branch and one unconditional branch. Here, I have only a single conditional branch.
Okay, got it. Thank you.